According to legend, the city behind me was founded by an orphan suckled by a she-wolf. He took his plough and marked out the limits of the settlement that would bear his name. His name was Romulus, and the city, needless to say, was Rome. In the centuries that followed, the Romans would spread their knowledge, their technology, their way of life across the known world. It was the greatest and most enduring empire the world has ever seen, and some 2,000 years later, it is a know-how that continues to astonish us. In 753 BC, Rome arose from the marshes of the Tiber River. As an eternal student of history, I'm awed by what the Romans accomplished using the most basic technology. Colossal doesn't even come close. Monumental buildings, paved streets and apartment buildings, a water distribution and sewer system that kept 1 million people healthy. Yet Roman technology built more than this city. As the empire grew, that technology spread, shaping the ancient world and reverberating into ours. To understand the role that technology played in building the Roman Empire, I had to go far beyond the capital, out to the frontier. Rome was the heart of an empire stretching from Scotland to Syria. Roman legions occupied 1/4 of the world that would become 36 modern nations. From these German forests on the northern frontier to the Indian Ocean, military might shaped the new world in the image of Rome. Here in Germany, that history is alive. Across the country, experimental archaeologists, like these modern-day Romans, search for clues to the Roman success down to the smallest detail. Reminders of the Roman occupation are scattered along the frontier. They reflect far more than military conquest. 2,000 years ago, the Romans built a wall here, and this modern reconstruction can give you a sense of the power of the Roman way. It was not just a physical barrier, it was, as much as anything, the edge of an idea. When Roman soldiers stood sentry here, they looked out over a land of uncultured bogs and forest. Behind them, on the other hand, was the Roman world. The legions marched for the glory of Rome and all that it meant. Towns and cities, roads and baths. Organised and well-trained, legionnaires carved the ways of Rome into the colonies, crushing all who opposed them. Roman military success relied heavily on the technology of others. After centuries of warfare, the Romans knew what worked. Much of their military equipment was based on designs adapted from their enemies. Their sword, or gladius, was originally Spanish. Their shields were Samnite. Their armour was derived from a Celtic design. The helmet was Etruscan. With one exception. The pilum was a Roman original. What made it so special was the tip. Shaped like a harpoon, it was designed to penetrate, impossible to pull out. An innovative design, but first, you have to hit the target.
Want to try?
Yes, thank you.
Like this. Straight on the target.
Straight on the target. Okay, we'll see how I go. It's heavy, huh? It's tougher than it looks. Now, in slightly more expert hands, this was an absolutely deadly weapon. And this shows you why. If it's thrown properly, a pilum will go straight through a shield and through the armour of the poor fellow behind it. Even if it doesn't, it was very effective because, as you can see here, it lodges in the shield. Now, a shield with a great big pilum hanging off it may as well be no shield at all. Roman soldiers were well trained in close combat to follow up the pilum attack.
Und los jetzt! Yo!
But adaptability gave the legions another battlefield advantage. Take the Scorpio. Originally a Greek invention, Roman innovations made it a highly effective weapon. A tightly wound rope used here stores the energy. The Romans used horsehair or, according to legend, even human hair for more power. Featuring a refined ratchet mechanism to control string tension and calibrated elevation, the Roman version was extremely accurate. Organised into crews, Roman soldiers could deliver death more effectively than the barbarian hordes they faced. Using these adopted technologies, combined with iron discipline and a systematic approach, the Roman legions advanced the borderlines of the empire. The Romans excelled at drawing lines. The line was at once the symbol and an instrument of their empire. These latter-day Romans behind me are enthusiasts who attempt to recreate the lifestyle of the 32nd volunteer cohort. And the reason why they're here is that this is the Salzburg, formerly a fort on the edge of the Roman world. Here was one of the most important lines the Romans ever made. The Romans used rivers and coastlines to mark the line between their world and the unconquered. But in central Germany, the local tribes fiercely resisted Roman rule. So the Romans built a border that cut across 350 miles of forests and hills, a truly remarkable piece of ancient engineering. This would be tougher in a suit of armour. However, I have just climbed one of Europe's most astonishing historical monuments. This is the Limes, the boundary wall that marked the edge of the Roman Empire. And while today it might look like a large mound of earth, it is in fact one of the most astonishing monuments of the Romans' engineering and building skill. There's one stretch of the wall which runs for 65 miles, with a deviation of only about 30 inches. You or I find it tough enough to cut a roll of Christmas wrapper and keep it straight, but the Romans could build an entire wall for many, many miles and keep it as straight as an arrow. The question is, how did they do it? Roman surveyors used an instrument borrowed from the Greeks, the groma. A rotating arm supported a wooden cross. From its 4 tips hung 2 pairs of plumb bobs. The surveyor sighted across one pair to project a straight line. Assistants placed markers. Sighting across the other set out a right angle, which the Romans used to plan their cities. This was an inspired application of a basic principle. For while the tools may have changed, the concept of sighting along several points to create a straight line is still the basic idea behind modern surveying. Once the line was laid out, special detachments of engineers began building the limes. Constantly on the alert for barbarians, they would clear the forest and build fortifications. Every 800 yards they constructed a tower like this one for quick communication in the event of an attack. Eventually there were more than 1,000. In areas where rivers didn't create natural borders, the engineers built palisades to mark the limes that sent a clear message: private property, no trespassing. And to drive home the point, they built forts every 4 miles, 200 in all, like the Salzburg, here in the Taunus Mountains near Frankfurt, Germany. Roman surveyors looked for the most direct route between 2 points. Following that rule, they built some of the fastest connections in ancient history. The Romans built a vast network of roads. Many were very solid. Stretching from the farthest frontiers back to Rome, roads were the veins and arteries that fed the heart of the growing empire. A close look at a section of one of their most legendary construction techniques, and you appreciate the challenge. Roman engineers had to be both creative and skilled. When the Roman engineers built a road, they built it to last. This is the Via Appia, the oldest and most famous of all Roman roads. It runs from the heart of Rome itself all the way down the Italian peninsula, a distance of more than 400 miles. Now, the Roman engineer used local stones, and he used the shape of the stone itself. He'd fit them together as craftily and as cunningly as a jigsaw puzzle. The tighter the fit, the more the water would run off, the longer the road would last. Road construction was based on a compact earth footing, with retaining walls and a ditch on each side. A small layer of stones in mortar was placed on top, followed by a layer of hard filling, probably gravel, and finally finished with a slab surface. Now, just how much traffic this road carried, you can see here from these grooves, which were dug into the stone by the thousands of wagons that passed along this way over the course of many centuries. This was one of the arteries of empire. It carried goods, ideas, and, not least, armies. Building as they advanced, the Roman legions forged the links that held the empire together. The greatest structures of Rome were replicated wherever the Roman way prevailed. Here in Rome, it's easy to see why and how. Their success rested on another adopted technology, the arch and its derivative, the vault. Without them, one of the greatest buildings would have been impossible to construct. The size of a modern football stadium, the Colosseum walls reach 4 stories high. If they'd been solid, the walls would have collapsed under the weight of the enormous number of bricks it took to build them. By using the arch, Roman builders borrowed a Greek invention to distribute the weight. Here's why the arch is so effective. From where the arch begins at the so-called springers, wedge-shaped stones called voussoirs are held in place by a central stone called the keystone. From here the weight is evenly directed down to the piers. Without the arch, there was no possibility of building a building as big as this one. It would have collapsed under its own mass. It is scarcely an exaggeration to claim that without the arch, there could have been no Rome. And if you step outside the city, you can see just how important the arch was to the Roman way of life. The Aqua Claudia is one of 9 aqueducts that together delivered 46 million gallons of water to the ancient city every day. Thanks to the arch, the Romans were able to create a vast water system. Here at Rome's Porta Maggiore, 4 aqueducts intersected before connecting to a labyrinth of lead pipes that distributed water throughout the city. This is where the aqueduct ended. But in Roman times there were similar fountains throughout the city, and that there were so many was because they were absolutely vital to the functioning of the city. Only the very rich could afford water in their own homes. So for Joe Public, or if you like, for Julius Public, this is where you got your water. And that's not all. Rome is and always was a sweltering place, and this functions much like a giant outdoor air conditioner. The fountains shoot water into the air. The wind carries the spray, and the spray cools the air. It's a pretty refreshing side effect. More than that, they were vital to the maintenance of public health. Groundwater was a continual health risk, and the water from the Tiber was absolutely filthy. So this fountain, and the many others like it, kept the population healthy. As the legions expanded the empire, they followed a basic principle. Public health relied on clean water brought in by aqueducts supported by the arch. The Roman engineers' long association with the arch was more than just a marriage of convenience. It was a love affair. For while a structure such as this one served an eminently practical function, bringing fresh water to the city, it did something more than that. According to the historian Tacitus, Rome's grand public works advertised Roman might. And nowhere was this more true than in the colonies. This scene behind me begins with the Romans. The river is the Rhine and the city is Cologne, its name a derivation of the Latin colonia, meaning city, the city that was founded here by order of the emperor. After colonization, city building was the next job for the legions, because Roman soldiers were more than warriors. Most had learned a trade before joining the legions. Across the empire, the soldiers were the engineers and builders. After 2,000 years of building and rebuilding, only subtle reminders of its Roman history remain in Cologne. Like today, there were sidewalks, piazzas and fountains that made the city a home away from Rome for the colonists. Eventually, 50,000 would call Cologne their home. The key was water, but not any water. To get to the quality and quantity they required, they built the second longest aqueduct in Roman history. It can still be seen if you know where to look. To span this valley with bridges like this one was far too expensive. They came up with an ingenious solution. This thing is an absolute marvel. Normally, when we think of a Roman aqueduct, we think of the vast bridges and spans that they put up across rivers and valleys. But in fact, it was much more humble structures, such as this one, which really did the heavy lifting. To build this aqueduct, they'd dig a trench along the side of the hill, following the contour but sloping slightly down. They'd face the trench with bricks and mortar, put up an arch, and then bury the whole lot under the earth. It all functioned like a giant fridge. The water that flowed through here was kept beautifully cool. So any citizen in Cologne was always guaranteed a glass of water that was cool, fresh and clean. Before water quality tests were invented, the Romans tasted and smelled the water. They looked for its effects on the people, whether their hair was healthy and likewise their skin and teeth. And if they'd grown old, the water passed the test. Only then would the engineers lead the water into the city. A city like this received hundreds of millions of litres of water through its aqueducts, and they had no tap, no faucet with which they could turn it off. So the water had to go somewhere, and this was the Roman solution. If we're going to understand how the city up above worked, we have to start here, down below. This is Roman plumbing, but it's much more than just plumbing. It's absolutely astonishing. We'd call it a stormwater drain, but to the Romans it was far, far more than that, because these drains run for hundreds of metres under the city, straight as an arrow, dropping a few centimetres every few hundred metres. It was a system of astonishing efficiency, and it was this that stopped the city from flooding and from choking on its filth. The Romans established a high standard of public health across the empire. The Roman world continued to expand. As the legions pushed the border further north following the Rhine, they established the northernmost frontier city at Xanten. At the archaeological park that's here today, research scientists and fans of Roman history are keeping the legacy alive. Part of their research is dedicated to understanding just what made the Romans so successful. In an effort to learn as much as possible about Roman technology, they conduct some fascinating experiments. Like reconstructing this model of a Roman catapult called a ballista. Assembling this war machine is something they only do once every few years. We were lucky to be here, even though no one was certain whether or not it would shoot. But one thing became quickly apparent. The Romans had a lot of muscle. Our guys needed a forklift. This is the weapon of mass destruction of the ancient world. It's an exact reconstruction of a Roman ballista or catapult. And like so much Roman technology, the invention is Greek. The perfection of that technology is Roman. Essentially, the principles and materials are relatively simple. The principle is one of tension, and the tension is stored in these ropes, in this case hemp, but we know the Romans used sinew, which are wound tight and maintained in a state of constant tension by this brass drum and steel bar. This is the sling that fired the projectile. It's made of sinews, like these ropes here, that keep the tension stored in the machine. It is, if you like, a colossal bowstring which was wound up and then released. Just how much force it maintained can be sensed from this arm, which apparently was one of the wearing parts of the machine. It would regularly give way and shatter like this. So it was a dangerous machine for the crew, but far more dangerous for the people in the firing line. Our modern-day Romans came prepared, complete with helmets and armour, and even the Latin commands.
Ballistari ad ballistam!
What we're going to do now is we're going to fire a Roman catapult.
Ansas aperite!
Now they're winding up the tension. They've got a hell of a lot of force in this thing. They're creating a huge amount of pressure by cranking it up at the back here.
Intendite!
This sled is coming back, and these are the levers that pull it back. Every time they're increasing the tension, and they can calculate more or less exactly how much force there is in this by counting the number of ratchets. So each click means another few yards, a few more dead barbarians. It's very, very tight. This thing is going to go off like, whew. Give it one more. Now we put the ball in. It's just a simple leather sling. Now we're going to fire it.
Et reactum!
Let's go. That is absolutely unbelievable. If you were taking on the Romans, you've effectively seen the equivalent of the ancient B-52.
Intendite! Et reactum!
This is the Roman version of a cannonball. It weighs about 8 pounds, and this machine could hurl this ball a distance of about 1/4 of a mile. No European army would have anything as destructive as this until the age of cannons and gunpowder. But believe it or not, this is a relatively small example. We know that when the Romans took Jerusalem, they fired balls weighing up to 30 pounds into the city. But part of what made it so effective, so deadly as a weapon, was its psychological impact. When this thing landed, being made of light limestone, it would shatter, sending a cloud of shrapnel into the defenders of the city. It was a weapon of shock and awe. Shielded by a city wall and guarded by a legion, the military founders made sure their new home was a reflection of Rome. I walked across the park to a place where Rome's influence on the city planners clearly left its mark. The building behind me may look like an enormous greenhouse, but it is in fact an exact replica built on a 1-to-1 scale of the outline of a Roman bath. The ruins of that bath lie beneath. Public bathing was at the heart of the Roman lifestyle, and this bath out here in the colonies is designed just like the great baths in Rome. Bathing consisted of a specific routine performed in various temperature zones, ranging from cold to a very hot 120 degrees Fahrenheit. It was all done with an innovative heating system called a hypocaust. I met with Dr. Norbert Zieling, Director of Excavation at the Xanten Park, to learn more about the Roman heating system. What are you going to show me?
I want to show you our bath. This room is one complete hypocaust in Roman times, of course. And what you see here is just a reconstruction of it.
So this is just part of the hypocaustum that originally would have been in the whole room, is that right?
Yeah, that's right.
Does this rate as a large one or is it a small one?
It's a large one.
This is a big one. And is this pattern of construction typical of a hypocaust?
Yeah, it's quite typical. You can find it everywhere in the Roman world.
And this is how the Roman heating system worked. In a hypocaust, literally translated the fire beneath, air was heated in a wood or coal-burning furnace and directed under a floor raised on small pillars. Clay pipes were built into one or more walls, and as the warm air rose, both the floor and the walls heated up.
It took a lot of time to make it hot, but when it was hot,
It stayed hot.
it stayed hot.
So in effect what you're saying is that this was a very thermally efficient system.
It was, yeah, that's right.
Regardless of where they went, bathing was a crucial component of the Roman way of life.